Okay. I think we're going to make a start as people join. Good morning, everybody. My name is Patricia Ryser-Welch. I'm with Alex Westenberg and Lere Abarategui. Sorry, lady, for mispronouncing your name. We are from Newcastle, north of England, and you will be pleased to hear that it's all nice and sunny now. I hope it's sunny where you live. Okay, I am a postdoc, a research associate in the university, and I work as well at the Open University, where I lecture a lot of computing courses, from distributed computing to user interactions, data science, even some data management aspect of computing, and of course some programming and mathematics, and some engineering as well. But my research currently are focusing on the computations and the statistics made available for non-disclosive federated analysis. Lady and Alex, do you want to introduce yourself? Alex?
Sure. So I'm Alex Westerberg. I'm a research assistant. Just joined the DataSHIELD team in January. And I'm just getting to grips with documentation and code testing, and fully understanding what the DataSHIELD federated analysis is all about. Later.
Okay. Hello, I am Leira Barrategi. I joined the DataSHIELD team last February, and I am also a junior researcher, and I am doing the documentation and testing of DataSHIELD general functions, and also I am working with IS Global, that is in Barcelona, to develop functions in DataSHIELD to analyze omics data.
Okay, but perhaps Oysten, sorry for mispronouncing your name. My accent is terrible. You may want to join later on when we've got a breakout session to either do some coding or either to have a chat with us. We've got some breakout room. You two may have some interesting discussion. Okay. Something worth mentioning, Lady and Alex joined us quite recently. They have yet to become PhD students, but they're full of talent, and because they are so good straight after the degrees or master degrees, we trust them well enough to do a full demonstration of DataSHIELD later on in this workshop. So it's the first time they're doing such an event, and they prepared everything on their own. So I've been most impressed so far. So they're not as used as to the rest of the people who attended the conference so far. There you go. Right, let's make a start, okay? So we got a few biostatisticians. That is brilliant. I mean, everybody's brilliant, because Lady, she's outstanding as well as a biostatistician. She teaches me a lot of things. I don't know much about it, but she knows a lot more. She's our specialist in that. So she will be in room 2 later on to do that. Alex is very good and outstanding at DataSHIELD analyst, and explaining how he feels about it, how they work, and how you do it. It will be in room 1 later on. And I will be discussing every other issues, from data governance to how to be a DataSHIELD or non-federated analysis programmers in room 3. But let's make a start, shall we? And have a look what we're going to discuss. So we need to bring some context first and look at the data. Well, we're going to talk a lot about the data and why we need to protect them. And later on, you will have a chance to have a go to how to break into some system. Quite simulated, simply, but it's quite an eyes-opening experience. So on one side, we've got like a lovely system, which is the weather, which in a way in United Kingdom, we like talking about the weather. It keeps changing all the time. And we've got a lot of, like around the world, a lot of data about people, but they got some differences between the type of data and we can do with them. So I became quite fascinated by looking at some weather organization who brings to our phone, watches, smart devices, the weather electronically to us. And what is happening here, that they got a big international collaboration of national weather services and a lot of commercial agreement. So national weather services are finding a way to make more revenue through some legal agreement, so that we can have access to our weather wherever we want to. So if we had been in Milan, we would have checked probably a couple of days before we traveled what type of weather we're likely to have, whether it's very nice and sunny and hot or not, so that we know what we can pack. And it's just brilliant, that thing. But okay, and what we've got there, it is part of a network and distributed system in a such way that if every national weather services are independent and autonomous, and the main system, I'm going to mention, for example, AccuWeather, or I could mention like Google Weather or Apple Weather, whatever you want to call them, then if one decided to drop off of the federation, the rest should be working together. It's just the local people, or the people visiting the countries, that will be missing, but the whole system is not going to collapse. That's in theory, but that's what is happening. And the way they do it, that's the diagram behind, if for some of you are aware of it, it's Microsoft Azure. So I'm not going to explain it in great detail. I've got the link at the bottom of the slide. I will make the slide available in the GitHub for future references. Have a look with that. But it is just to show it's a complex architecture, and it's based on cloud technologies. And Microsoft big data warehouses and data centers are quite complex elements. They're all scattered around the world. Actually, where the points of the internet connect to with big cables and satellites there. And they got a lot of machines installed there. And some of them in this architecture, there you've got some storage, and you've got some data collection. And on the right-hand side, where you can see this kind of mobile phone mast, it's where basically the data is collected and fed into this Microsoft data center. So the minute the data leave the data center, this weather data, basically Microsoft, because they've got strict commercial agreements, are the owners of the data, and they can do whatever they want with it, and they store it. And I think they store it for a long time, because you can go back quite a while in this system. Oh, we've got some statistics there. And then once you've collected the data, you store that. They do a lot of complex calculations or big number churning, and they combine the data set, data processing in the data processing. And once they've done that, they use some computation to forecast the weather using some statistical and probabilitical analysis and some visualization of results. That's basic data science. That's using massive system. It's been done since the 1950s. AccuWeather has been going and use all the technologies. But what's so good about this data? Well, the weather data are not related to any identified or identifiable individual. Telling me that it is now sunny in Newcastle and 17 degrees, as my watch telling me, is not going to identify, unless I'm telling you now, and you're trusting me that I am in Newcastle with some of my colleagues there. Okay, that's the way I might know it, but it's not going to identify me based on a big data set. Okay, no individual can be directly or indirectly identified from the weather data processed either. It's just a lot of numbers, some probably longitude, latitude, some humidity, percentages, and all this. What the weather people uses, and they simplify it from us. So that's no risk at all. The data no data needs to be anonymized, because unless probably it's army-based data, well, they might not like to know about the weather, perhaps. I cannot see any why they should not be processing it or be identified there. And as well, finally, the processing the weather data, I'm on the right bottom left corner now, boxes, do not need to be the weather data does not need to consider the content of information, the purpose of processing, the impact effect that processing on some individual, because there is no relation whatsoever to individual. So these data is just brilliant. You just take them, you analyze them, you make them available to everybody, and you learn a lot about the weather on this planet. But what about if we move now onto something completely different? Let's imagine we've got 15 countries who wants to get together. And what they would like to do, they would like to share information about preterm born babies. So then we'll have quite a lot. We'll have two individuals affected by the data, describing by the data, the mother carrying the baby and the baby itself, the preborn baby, and once the baby is born, about they write as well. So they're going to connect to get the data over a 30 years time span from when they're born or from when they have been born and what type of treatment they had, and that's it. So it's quite highly personal data. Don't know if you're a parent, that's it, the treatment, that it's quite close to our heart. We don't want the rest of the world knowing about that, perhaps. And what they really would like to do, they want to inform healthcare and social and education policy so that perhaps these people who have got some born earlier may have some different needs, some others that we don't know, and we would like to know that. So unlike the weather, this data got quite a few issues, and I'll come back to that. Okay, we can identify some people, some individual, and strongly related to some individuals. So we cannot suggest and we cannot start to share the data across Europe and in DVDs or CDs or anything like this, just in case they lost it. This type of thing has been done in the past and data has been lost as well. Or even store them on a laptop and traveling with them. That's not something you're likely to be doing. You can tell me they could be on paper, and that's got some real issues as well. The individual can be directly or indirectly identified from the population data processed. If there is a small village, for example, some small cells data, individual can definitely be identified from that element, which can be which people might not want to. The data needs to be truly anonymized. And when I say truly, it doesn't mean just hiding the names, as you will find later on, before they are shared or processed. And the population data needs to be considered, the content information, the purpose of the processing, the impact and effect of processing on some individuals. I mean, when I was preparing for this slide, we didn't have the political unrest in the States, or the most recent ones, I should say. And I think nowadays, the more I'm thinking, the more I'm speaking, is for certain people and certain region where some communities may be ostracized or some communities may not be welcome, then probably your data may be saying something there, and some bias could be definitely be passed onto the system, onto our calculations. That has been done in the past. It's completely unethical, but it has been done. So we have to be quite careful, and this aspect comes into it as well. So let me go back to the previous slide. That's a Preterm, so my apology. So that's the data. Now we've got another project here, which is called a EUCAN-Connect. Unlike the Preterm's babies, which the project has been finished, and we'll discuss that later on, we got a current project we're working on, And we've got 13 experience organizations, and they're across Europe and Canada. And these people want to make available some population data accessible to global scientific community in a such way that organization from across Europe or wishes to join the consortiums can study this data, make some comparison, do a lot of processing and learn about it, and so that we can move on. And what we're doing, got a fair federated data platform, which is mean findable, accessible, interoperable, and reusable. It's on large large scale pool analysis with some privacy protecting features. And these privacy protecting features are very important because the preterm study and consortium would have never took place and started and protect and happen and learn about it. And for that, and for as well the EUCAN project, we will be able to move on the population study and medical research as well. So what this workshop is about now, what we're going to, we have made the differences between individual person level and other data, which it was just to bring everybody up to speed. I'm sure some of you are aware of that. And like this, we all got into the context. We're going to explore the issues with federated analysis and sensitive data. And what I want to make quite clear now, sensitive data, and I know, I think in the States, when the president first came in office, they had decided to share on a big data center. I think it was the Amazon one, some medical data. And now I think some people behind the scene are trying to stop the deal because they don't think it's a good idea. So there you go, even in the States, they're thinking again about it. So we have a look about federated analysis and sensitive data. We'll have a look of experience of disclosive architecture. You will be able to experience it in some simulation code. And we'll discuss as well some architectures and what we're doing and how it can be done. We'll look for the DataSHIELD architecture, and then we'll have some DataSHIELD demonstrations. So I think it's time for a little break now and look at the chat if you've got any questions. Oh, I'm glad to see here we've got a few people in data protections here, which is great, interesting. That's fine. If you got any question, ladies and gentlemen, are you just happy? Or are you still there? I'm just checking that perhaps. No, okay, right, so we can continue. Good. So let's have a look at some definition. Okay, so we've got some data scientists, we've got some biostatisticians, we've got some people interested in privacy of data, which is good. But what we're doing here, when we do some data science analytics of statistics, they keep changing the term depending on how people, the term's getting more popular or not. When I started to do this type of things, I think it was called data mining. Now it's called data science or use of ML or whatever they call it. So we ask the right question, manipulate the data set and create some visualization to communicate the results. Yes, that's what we do. And what I like interesting with this diagram is that you've got some computer science using big data. At the bottom, you've got the subject master, and that's what I call the domain, your knowledge domain. So for example, if you are working with client data marketing, your public domain, your knowledge domain, it's your marketing of your particular area and the type of data you have access to. If you're working like with populations data or cohorts, like we call them, then basically we will know the people who got owns and doing the data governance and do all this data, then we'll have a good knowledge of these data sets, okay? based on the specialty. So that's what we've got. And in the blue bubble, we've got the math and the statistics. Yes, we have to know the math and the statistics to do our job. And if you look at it, the machine learning, it's between computer science and big data. Sometimes it's working, sometimes it's done, the ML, but that's what we've got there, and the math and the statistics. And often, and especially for all what we've learned there, a lot of people have been applying in ML a lot of advanced statistics and probabilistic model to find some lovely pattern, and we're discovering quite some well-known fact, which is great. So hopefully something new, like the biologists needed to do with the pictures and the birds in the forest there, it was fantastic, will be fine. But what, identifying birds in a forest for biological research, that's great. But what happens if they can identify us personally going to town and not wearing a face mask, for example, because we left it at home? Could we be prosecuted there? Can we be identified with that? So that's this aspect there we need to think of. And if you look at it between the subject matter expertise and the traditional research, the blue one, then we've got the math and the statistics, we've got the traditional research. And later on, we'll look at the dangerous software. And data science, if you look at it, bang in the middle of all that. So data scientists, ladies and gentlemen, we should be able to know all that to do our job. And it's quite a lot of knowledge. And some of us may be more on the math and the statistics. Some of them may be more about computer science. Some of us may be more on the subject matter, but we're all data scientists. And we're quite a multidisciplinary discipline, and we all work together. Okay, so federated system. What is a federated system? What we've got some collective agreements, many standards. And when I'm talking about that, I'm more talking about not only the legal agreement about the data, leaving us and people having it, like the weather data, but as well the standard like the TCP/IP, the HTTP, the HTTPS, where we put the security added to the HTTP, all this computer standard we use just to be here today in our workshop, and all these elements there. We've got as well an interoperation of several distinct network computer systems. Yes, that is as well needed, a bit like our weather data there. It's often, they often interact with each other. And if they're not networked, well, they're not federated by default, otherwise they would not be. And then we've got the heterogeneity in terms of hardware, software, and operating system and network. So some of us here might be on Windows, some of us might be on Linux, some of us might be on a Mac, but we're still here, we're still doing it. And federated system often address this type of operating system, and we're not limited or stuck in one element of the type of hardware, one type of let's say operating system. We all independent and autonomous from each other's. So if I go back to our preterm babies, so for example, if one country decided to retract the data, it would be a great loss for everybody of this community and consortium, but the rest of them will still have access to it. I'm not going to talk about politics here. Now let's have a look at the right bottom corner. We've got the distribution of analysis. When you federated analysis, you just distribute them in different locations, perhaps, or different computers, so that you churn more data more rapidly. Data distributed about multiple databases as well. That's another very big element in federated system. And what we're doing, we've got different elements of computer network. So that's what makes a federated system, and that's what a lot of them happen. And at the start of the conference, we had this lovely system of this person called one of the winner of the COVID-19, and the COVID-19 person connected beautifully and very usefully all this COVID-19 data so that we can have access updated raw data, download them and work with them. So he created this great federated system, I believe, through the CRAN and through R, and how to work it out. But none of this data had personal data in. They were just cases, latitude, and well-detailed data, but they were very, so we could not identify, less likely to identify somebody out of the crowd, basically. Perhaps, I think it was quite safe. So, example of federated system. Well, I've just mentioned the COVID-19 one. We just had a look at as well something called a river called Meuse, M-E-U-S-E, where they got records of data, and our packages got loads of them about that. And we've got, well, like the AccuWeather system and other product as well to do that. But then sometimes we all use a mobile phone, or many of us use a mobile phone, and perhaps do some shopping from a mobile phone and do all this thing online. And sometimes some data is being collected from people's mobile phone for commercial purposes. And I'm going to add that here because I feel strongly about that. And nowadays, our mobile phones and who we come in contact with can help us to trace us and inform us that we may be in contact with somebody who had COVID-19. And as a result, we may need to be tested ourselves. And it's done a lot of good work. Now, the reason why it's in orange there, because why technology, I think, has two tranchants. So there's something to protect and trace and do all this element, but there is something as well to control population, and that it's up to us sometimes to say, yes, I'm happy to take part of that or not. Okay. And the one in red, where we got the sharing population data and personal data, and based on that, we can find patterns about identity and the individuals and personal information. And that quite people may be a bit, it's in red because it's not very good if we can be identified. Okay. All right. Okay, so data brings many responsibility. So I am not a lawyer. I am not a solicitor. I am just know the law, like the GDPR, because it's the most famous one. I am just aware about some international law, having worked with very sensitive data, not only medical one, and different organizations where they like the MI5 of data protection, and they got loads of legislation kicking off. So there is specialist solicitors who do that. And if you got any issues with that, go and talk to them. But what we need to be aware about our data and our data governance, and it needs to be lawful, fair, and transparent. So for example, if you work in marketing, I know there's a few marketing people here, or if you use some biostatistic data for personal purpose, and you know some individual gave you the data to use for this purpose, you need to tell them how and why you're going to use the data. And if later on you think like, oh, I've got this data set, I may be able to use it to my new research, you cannot do that. You need to contact again these people and ask them, okay, you gave this data, gave us authorization to do this type of work. Would you be happy if we use your data to do further research? And that's what we're going to do. You cannot do with your new project without everybody signing. And if somebody says no, the data need to be removed from the data set. That's why we move from lawful, fair, and transparent. Okay. Then we've got the purpose and limitation. I think I just brushed it about it. You know, like biobanks, they often contact people. We would like to have your data, and we're going to do this element with that, blah blah. Would you be happy also? And if you say no, that's fine. They just don't use your data. So always, it's a limitation in time and the purpose. We cannot reuse them. Data need to minimize as well. They need to be accurate as well. So what we need to do, we need to make sure whatever the outcome, it needs to be accurate and not portraying perhaps people in a certain way they should not be. They got a storage limitation. So once you finish with the data, you should be deleting them. So for example, I've got access to all because e-Rum sent them to me. I think I did tick a box when I went to e-Rum to be shared to the people involved within e-Rum. And after this workshop, I will be deleted your spreadsheet, my spreadsheet. If I've contacted you last night, contact us by the DataSHIELD email, please. That's this type of storage limitations, okay? It needs to be confidential and some integrity, and you need to be accountable for it. So for example, if somebody, and many firms does that, and the press got loads and loads of that, somebody, for example, hack into some system and get the data, must tell the people what happened and be accountable for what is happening. Or for example, if the data are saved on a USB stick and the USB stick got missing, you have to tell the people what has happened. Because if the USB stick ended up the wrong type of hands and they know all about your details, then people need to be aware of it. That's the data protection principle, and that's the way we need to be, and the data governance need to act on. And that's why as well, a lot of things in medical research is having access to the data. So what is a disclosive analysis? Well, it's a lot of big storm like we had last night and rain, just to show how we need to take that very seriously. So we provide information that violates any legal, contractual, and ethical undertaking. So if you, the ethical undertaking, everybody understands differently what means is ethical or not. But some people, you know, they go to, for example, to a hospital and they said, yes, I'm happy to my data to help to the development of that treatment. But then if, for example, the drug companies get access to this record and you haven't said, but I didn't want it to be for commercial purposes, then it's become unethical. So when we're talking about ethical undertaking, the patients often has to have to be informed what is happening and what we are doing. And my colleague Madeleine Notag, who now is at Glasgow University, she's done some outstanding work about that and implemented a lot around Newcastle and North of England hospital, this element, so that patients are in control and understand why we need the data and why and how they can retract the data at any time. Then we've got the data owner has entered into an agreement with the third parties. Individual can be identified. So let's imagine you end the hospital for whatever treatments, and then, well, you are being identified by the data. That's completely disclosive. Nobody should be identified by that. And one that could be, for example, I've got bright red hair, definitely like this slide here. So, for example, I bet you if you look on our website, you will be able to see me on one of these pictures straight away. And now basically, well, it's my fault there. I'm just referring to me that. But for example, if you get this data available like bright red hair into your data set and you remove my name, then somebody around the area who might know there is only a handful or not many people who have this type of colors of hair, they will definitely be able to group us and identify us. That's this type of elements we're talking about, okay? So whatever data got a data agreement within the third parties, and nobody should be able to be identified, okay? What is disclosive as well? We make use of data without those agreements under which sensitive or personal information can be shared. That's another element, and we need to be very careful with that. Data governance needs to make sure basically people know what they know with this data. So I don't know what it means for you in marketing, but I don't think it's a borderline disclosure. But for example, well, some of us may be using Amazon, and I remember once I went on holiday and I bought loads of books from a certain author. And then I've got a Christmas set of fairy lights sent to me, so much discounted, I think ridiculously low prices. I think I paid £2 for these good quality fairy lights. And I look at them, I said, I didn't order that. How come is that? Oh, it's so cheap. Well, I'll keep them. That's fine because I love them. And deep inside me, for some reason, I have been thinking, gosh, I would love to have some fairy light, but I never looked on Amazon for fairy lights whatsoever, or on my phone on any website whatsoever. I may have been in a shop looking at them, but that's it. So whatever happened with the probabilistic systems and Amazon using it, they are predicted. And I like so much this author, I bought all their book, then I should love this fairy lights. And I find that a bit worrying, to be honest with you, but there you go. So let's go back to our diagrams here. And as you can see, there is elements of disclosure we need to make sure we don't do. And you're going to experience that later on. Okay, so first of all, the math and the statistics can be disclosive, and you will see why. The disclosure of data often appear with the subject matter and the expertise as you've got. So if you know well people in north of England, especially in Newcastle, you will know how many people got bright red hair, and you can identify us or probably know our names. That is, for example, one example with it. But especially with rare disease, rare cancer, form of cancers, there are only so few people who've got it, then they can be identified quite easily from this data if you know the subject matter. So that is why we have to be very careful with this type of data. You can get some dangerous software. They can as well lead to disclosure of data, and we have to be very, very careful with that and make sure they're very secured and there is no data leaks and all this aspect. So there's different element of disclosure. And before we continue, I'm going to highlight that Professor Paul Burton, and Dr. Dimitris Avram, who are a working part of the team, they have been doing that for many, many years. And they've got this sixth sense, and in our team, we've got this sixth sense through them. What is disclosive or not? And in a way, we have yet to find the direct science about it. When we develop our functions, we have to discuss with ourselves, thinking like, that would be disclosive, wouldn't it? Or what would happen then? Or blah, blah. And we've got as well one of our colleagues who now moved away to another university. We call him the gatekeeper, Dr. Ollie Butters, and we have to pass through him. And it's always very good to say, actually, no, because you can do that, and that, and identify the data, or you can do this element. So disclosure of data is not just a matter. It's not something straightforward. That's what I'm trying to see. And it takes a lot of effort on a computer system security aspect of it, not only on that, but as well on the subject expertise, and we're all unique with that, and as well on the mathematics. And it's quite a multidisciplinary element with it. Right, so what is non-disclosive analysis? Okay, so again, it's similar boxes as before. The sun is shining. And then what we've got, then all the provided information respect legal and contractual and ethical undertakings. The data owner, we have an agreement with the third party that no individual data should be inferred. Now, I use the word inferred because often, and I've got an interesting article on our GitHub, and if you got two different types of data sets, you can put them together and learn a lot. For example, a couple of years ago, when we had about Brexit, I'm sorry to bring politics, A lot of people wrote to discuss to stop Brexit on the government onto one of this online signature thing. And you put your postcode in, your email address, and what else in your email address on it. And from the postcode, we were able to compare quite easily the number of people who voted for the MPs, the number of people who signed that petition, and the result was just immense. You could definitely see quite some, and the politician probably should have seen something quite interesting coming out of it about this element to learn about the population in each region, and that's it. But then again, no individual data could be inferred in that case, but you can still link it. But in a way, the New York taxi, or even with Netflix or our email address, we watch some of us may be watching a Netflix movies. We've got an email address and we love it so much, that movies. We got onto our Facebook afterwards and we say, love that movie actually. And if you've got access to Netflix, and you've got access to the Facebook, and you can try to merge them together, by the time probably and the date, you can probably guess what I have been probably watching. Well, if I was going to do that, obviously, or what individual have been watching and when. I hope this makes some think the type of inference and you can start to be doing. Okay. When we make use of data, when it's non-disclosive, we make use of data of those agreements under which sensitive and personal information can be shared. Okay. So when it's non-disclosive, we're sharing some personal information, but we cannot identify all our the people there, and there is a strong data governance on the box on the right hand side. Okay, before we go to some discussions there, we've got 3 different people. We've got some data custodians of governance, we've got some data analysts and scientists, and we've got some developers. And in my mind, the data custodians and governance, they control all the access to the data, and they're the people responsible for data integrity is sustained, content, and as well the data content and changes are audited. That needs to be done, and the technical controls safeguard data correctly. So they've got quite an important role there, and they need to be, it's the people who are in charge to release the data or not, under which circumstances. But these data custodians do affect us, data analysts and data scientists, because what we need to do to respect the data governance custodians, we need to prevent revealing confidential and damaging information related to individuals. And again, to bring back what's happening recently all around the world about certain life matters, and there had been some unethical use, I think, of machine learning by accident, where the learning data set has been including certain people of the community in pubs in certain parts. Yes, they've been arrested, pubs, they have done that. But then the machine learning learned and just suggesting that these people of this community are more likely to commit crime, which is completely incorrect, because they hadn't had a little snapshot of the whole nation, if you know what I mean. So that's why we need to be very careful, and that it's damaging for these people of this certain community, because we start to label them, and we have to do that. We have to be very careful about that. We need to prevent revealing results that use small amount of data, and you will see later on why. Because inference can be used quite easily to reconstruct the data set. We need to prevent revealing information that can be combined with other data sets. It's a bit like the Netflix and Facebook element, where basically the time and the day, then we can start to combine and start to look at the data, see what's coming out, and see like, oh, right, yeah. So this person probably has been watching that at that time. You never know. And again, if you look at the Facebook, we probably got our date of birth. We probably got both system got our date of birth. Both system got some personal information there, and they can be used for our taste and that. So there you go. And here we are, the developers, the other people. Developers have to make our infrastructures basically store data and monitor access. Okay, and they need to be secure. They need definitely to be secured. The security of communication protocols. And that, in my mind, it doesn't not only involve the use of TCP/IP and HTTPS and all this access of that. It's as well involved when you communicate the data, probably just using emails or telephones or everything, and how data sometimes is being shared with people. You need to implement statistical control in statistical methodology and visualization tools, and we'll discuss that later on. And you probably, if you wish to, you can experience this in some fantastic simulations there. And then you can produce some tests that continually assess this criteria. How can you tell the data custodian that, yes, all that is met if you don't have the proof that it's been in place? I don't know. Okay, what I suggest now, I need to breathe a bit. We can ask some questions and answer them. Right, Alex and Lady, have you got anything exciting for us to answer? I hope you're enjoying it so far.
We do have one question already from Masha.
Oh, brilliant.
I think it occurred around slide 18, saying, how does storage limitation work with the demands of many journal editors to keep data openly accessible on data repositories?
That is a very good question. That's a very good question. The way I could give you an example, actually, perhaps, to answer this question. Recently, somebody contacted us because they got quite a big, large data set about some instruments they used on some people in some hospitals, and they looked at some patterns, and they're finishing the PhD, and they want the data to go somewhere to be used for further research. So they contacted us so that we use it. So we said, Grant, great, we would love the data. But the first thing we did, we had a meeting about it and said, how are we going to use this data? And we cannot have access to look at the data yet, because we haven't had an agreement with the person who is the data custodian, these PhD students, which is the end of this research. So what we had to do before the data gets wiped out, we suggested, how are we going to use the data? And we thought, like, okay, well, I would love to use in my next paper. Personally, I would love to use the data, because if 5 gigabytes of data, that would be great for our computational element to see where it's working or not. And what we need to do, we need to ask if we can use it for publications. So if the person says, no, you cannot use it for publications, we will not use that and publish the result, full stop. Having said that, if they agree we can use it to do some testing on our system to see how robust it is, then we will use it. So we have to be quite careful about it. And it's the data governance that will let us, whether or not the journal people, editors, can have access to it or not. It is quite a problem, Masha, about that. That is why the type of architecture we're using in DataSHIELD can help, because if the data governance give you access to do that and publish the work, the people should be able to have access remotely to the data and repeat your experiments and repeat the code you are making available, so that they do it, but they do not have access or cannot identify any individual. So that's the way to look at it. But before we do publish our papers with a specific data, the data governance should have say, yes, the data, yes, they have, the people of the reviewers of the journal paper can have access to do that and repeat your experiment. Did that answer your question? Majid, do you have any question? Because I see you in a market research. And I'll be interested in what's your views on that, perhaps. I'm just waiting for you, perhaps, to type something if you wish to, but I don't want to put anybody under pressure. Okay. Right. Let's have a look why these cats are about, and that's it. Okay. So what we're going to do next is to have a look how we can experience disclosure and prevent it. Okay. And often disclosure is not something as we may expect it. I'm talking a lot about inference. I've got a lot of Sherlock Holmes. We'll discuss in our team a lot of Sherlock Holmes about how you can put things together through inference. And look at this lovely cat there is trying to hide away in a box, but then we can still, based on the features, he or she decide to show us, well, see, he or she is a black cat and with a different size and we can definitely make who he is or who she is. Okay. So we've got many forms of disclosures. We've got the identity, got information about individual people we do not need to be aware of. Yes. And on that one, okay, I may have received my lovely little lights, fairy lights, which I love, but how is that? I wonder what Amazon now is doing with my name against this fairy light, and that still worries me that bit. Anyway, and we provide access. We've got as well many aspects of disclosure of providing to the data, access to the data. Oh yes, that's one of the main one. You've got a client-server coding and see how you can prevent it. And you've got a number of constraints on type of analysis to complete. And then basically there's many forms of disclosures, and all that together, they can be quite part of this dangerous software. Okay. You're going to have a look at some data which I got from the Goodread website, and I have used only classics authors because I didn't want perhaps to do some analysis of current authors with very low scores and put them give them a bad name, just in case you wanted to buy their book and read them or borrow them from the library and think, oh, but they changed my opinion because the Goodread score they have some bias and they don't like them. Okay, and you will see, and we're going to assume this data is highly sensitive, and you will see a lot how we can infer with this data. So you have a title, you've got an author, you've got a Goodreads score where people vote about it, whether they like it or not. You've got some word count, and then you've got the year of publications. Our simulations will be using a client-server architecture. Now, for install DataSHIELD, it can take quite a little while how to do it. So 3 hours I thought wouldn't be enough. I thought we could use some X6 classes, and I'm providing most of the code. Don't worry about it. You will be fine. Just to simulate a server, and we'll have one in Newcastle, one in London, and one in Edinburgh in Scotland. And we will have some computer analysis script connected to this server and do some different type of analysis. Now, a word of warning, I didn't implement just for simplicity users and password, the minimum thing we put in our system, because I thought, well, that's the first breach of it. and then it would make the things more complicated than it is. But if we use federated analysis, you definitely have the user and the passwords, okay? But we're focusing on the data here. Okay, so I'm going to copy a link in a chat for you, and you can go into GitHub to download this. To download this this from GitHub. You will need to have an account from GitHub. My apologies for that. To download it or clone it, and you will have a wiki. A wiki attached to it, and we'll have some explanation with it. Okay, I'm going to show you that in a minute. If you do not wish to do that, you can come in a breakout room, number 1, and talk to Alex about analyzing data. You can go and see Lady to talk about omics data in non-disclosive federated analysis, or about your work. You will be fine. And you will be able to discuss with me as a DataSHIELD developer about this data governance, or whatever aspect you would like to discuss with me. That will be fine. So we've got quite a choice, and you can pick and choose. That is fine. If you've got any questions about the developer, go in room 3 and about the exercises, and I will be there to answer them. Okay, so I'm going to change my screen now. I'm really sorry, something will go blurry and not very clearly. And I want to show you how the GitHub looks like. So here you've got some code, and you will have some folders, which is called A tutorial disclosive. And you're going to go to e-threshold. And so you've got some RStudio projects, some R projects there, and you will have 3 types of different scripts there. Let's have a look with that. One, it's called main disclosive, and they always start with main. If you open that and just click on the source button, you will have loads of elements and the script will work. And if you want to have a look how the server structures, which I strongly encourage you to do it, you can have a look in the disclosive server script, and you can have a look at this disclosive client. Now, we've written for you a lovely wiki here, introducing all these elements that we've got there. And what you can do, you can click on the disclosive simulations, and you will have some even more information with some code to explain you how that works and what you will learn. And you will work, the journey will be moving from a completely disclosive system that works well with weather data to one that's working better for personal data. If you don't have time to finish all that, that's not a problem. Here, I need to add the link here. Alex, I need to add the link there. Ooh, I have a slap on the wrist for me, sorry. There. Once you've done all that, if you wish to go back later on, this GitHub repo will be there for you to use. Don't worry, you can use it. And then what you can do, you can have an overview of DataSHIELD if you want to have a look at installing DataSHIELD and do all our introductory tutorial in your own time. So you've got quite a choice here, basically. But if I were you, you can either come and chat to us on our room, or you can do the coding. Right, there you go. Okay, so, and we'll be back in 40 minutes, by the way. Yeah, 40 minutes, which is yeah, 40 minutes, which is 10 past 10 in the UK, 11, which is 10 past 11, so 10 past 11 where you are, basically, if you are in continental Europe. So, any questions? Right, so what I suggest, I will join my room number 3. I will join that. And after that, in 40 minutes, we'll review all the findings, look at how it's done with DataSHIELD and R and other technical elements, and then we'll have a look at the demonstration. Right, let's go in my breakover room. Or is it the moment where we get all nervous when where people cannot get our GitHub account and our exercises? What do you think, Alex and Lady? Okay. We're going to start in a couple of minutes if anybody wants to join us again. We back now. We'll see what people are doing. I'm on that. Oops. Right. How do we know everybody's back now? People have to tell us in the chat they're back. Please let us know.
Hello.
Yeah, we're back. Excellent, Serena. How did while we're waiting for everybody's back, what did you think of the exercises? Oh, hi, Christoph. Great. Hello. Excellent. Good. I hope you have found that useful. And if you haven't finished it all, it's always so hard. Whether you can go back any time through that, and you can go back and do your learning and share with everybody else to learn about that. Please free and just quote us. That would be fine. Thank you very much. But I'm going to stop my camera, like this. We can all have more room on our screen, and we can continue with our. Okay. So what we've been doing, we had a look, we've done a look at the simulations, and yes, we used some more advanced R or object-oriented programming classes that's been done in a functional language. And the reason why we use it, it's because we can add with an encapsulation, hide the data behind the router. There's a lot of similarities there, but DataSHIELD doesn't use this technology, is using another one. So, but it's just the simulations. Okay, so let's move on. Okay, let's have a look. So what we look at it, we looked at providing access to the data, and what we did, we just provided the straight access to the data by just keeping it completely open. So if we would be where the data will be just fine, because that's what we want to do. But if, for example, you've got somebody like Joseph Conrad who doesn't want to know they got the lowest score there, I never read the book, so sorry, Joseph, then basically that way it might be basically a bad idea to keep this data in such a way, because then they're identifiable. So then once you have done that, we just had a look at how to identify, how we can stop people identifying people. So Elton John probably agreed to go on a Simpson and to be drawn in as a Simpsons way, and he's recognizable, but we don't want to be recognized. So what we did, we removed the name of the author, basically, and we just left the title. That's fine. That's okay. That's better, because I cannot identify it. So some systems are there and open hospital data, and the anonymization probably can, may only do that. So we have to, or just hide only elements of the data of the patients, but still with some domain knowledge, we can find it. And then we remove the title, because if you looked at the data and you knew who wrote basically, I've forgotten the name of my author there, The Heart of Darkness, then you would know basically is Joseph Conrad. That's just simple inference. And if you still don't know that, well, what would you do? You will just use Google and research it, and you will find it. So what we left with, we just remove the name, the title, and the name of the author, and we've got just numerical data. So we've got the grade read score, we've still got the number of words, and still the year of publication. And that doesn't stop us to do quite a bit of research about it, because looking just at this data, you can, as a data scientist, probably see for a link, if there is a link between the number of words and the year of publication, perhaps. Or you can have a look, maybe a link between the grade read score and the year of publication, or the number of words. So you can see a lot of research, but without identifying Joseph Conrad and his Heart of Darkness. Okay, so that's what, and you just remove the data. That's it. So, for example, if you don't want some other elements that may be for competitions or for marketing purposes, that's not only personal data or airline companies, you just remove the airline's name basically from your data set, but that might not stop you to still identify elements which may go wrong with those elements you're working with these airlines. Then we look at synthetic data. Now, that's a very basic model how to use synthetic data. It's far from being perfect. The reason why it was far from being perfect, because synthetic data and data science has been, in the last year or so, being something quite hot, and people are trying to say, you must use this data, you must look of that. The reason why we use them is to validate some mathematical model, and that can be machine learning. That could be more different advanced statistical or probabilistic model or other mathematical model. But what's important with good synthetic data and all the characteristics of normal data that basically are there, and all the sensitive content is being removed. The synthetic data is generally made of to validate of mathematical models, and we often compare the real data against one generated by the model. Now, a word of warning, for example, some synthetic data they use to validate machine learning, they often try to match as close as possible just to match this machine learning or advanced statistical model. And then when you try to use it for something else, the thing doesn't work because it's only fitting for only little element. And there's a lot of relationship between the data that's more complicated than other. Our world is not, the observation we make with our world is not as ordered as you may find in other elements. So what we've got the original data, and I chose only the data from Edinburgh, from Scotland, because it's quite 5 data. And I use a normal distribution. I've got some normal distributions. And what we've got there, the normal distribution didn't look at all at the relationship between the number of words, some and the year as well it's been published, so that it's really all over the place. And for some reason, look at the first one. You've got like in 1918 and you've got quite a large amount of words, but the first one, it's far from being perfect. It's got something around 1934 and the number of words is much smaller. So there was a lot of relationships and observations there that's been lost to the data. So then we use a multivariate normal distribution who can help to make better this relationship. Now, if you were going to have a look at this, if you were going to have a look to this data and look at the multivariate system, it often look in more than one dimension and try to find the relationships between them to recreate the data. So let's have a look how the statistical analysis of them are likely to work with them. So that's the original data set, the one with dataset.o. And then you've got the normal data distribution, and M is for multivariates. So look at the maximum values there. For example, we had a range between 1918 to 1961. And now what we've got for the normal distribution for the year, we've got something from 1916 to 1943. So we lost quite a bit, a few years there by just doing that. And have a look now in the multivariate one. It's far from perfect either because the minimum year is 1910 now, earlier than our normal data set. That's not really accurate, that bit here. And as well, it finishes much earlier that the original data set. So the data appear to, for the years, a bit more condensed than the previous one. And if you look at the IQR definitely shows that quite well between the 3 data sets. If the number of words is far from perfect as well, It's slightly more compact as well for a long range, by the way. So if I was going to use this data set to validate my model, I might not be quite correct there, basically. So I decided to put like a bit of a table with the traffic light systems there on my table there. And as you can see, only the data set 2 and the data set 3 there is in green because it's quite close than the original one. But using the multivariate data set, the normal distribution on its own was not very good, not very effective. That's fair enough, that's all right. Now we know we shouldn't use it. But again, if you look at it, the data set 2 for the grade read score and against the year, the correlation there, it's not perfect either. That's what is in yellow. And the correlation in data set 3 with the year and the number of words is not far being perfect. So some of the relationships has yet to be fully representing our new data set. So if I was going to validate any model with the data, then I may find some result that's not very accurate. That's not very good at. So we did remove the verdict. We did remove no sensitive content. It's all gone. That is fine. But the reason why here, the main problem was there. So we didn't have enough data to do some synthetic data, to find the synthetic data. In some of them, we had only 5. That's not good enough whatsoever. Just for this demonstration, we use it. And if you look at the packages in R that using them, they always got a word of warning saying it might not work for every data. And often they use like hundreds of thousands data just to find out what's the best correlations between them, what's the best way how to do them. So you have to have quite a lot of data to have something of good quality. The spread of the data doesn't definitely match the original data. They've just been compact together. I think they've just been in a standard deviation there, matched between in the S, the standard deviation, and the outliers just gone. That's what happens then. That's not very good. And that's come from the normal distribution definition. The relationship between the fields have yet to be fully replicated. And if you think of it, the number of words against a year, that's something quite random. And it would be very, very challenging to repeat it. And we cannot basically validate any mathematical model correctly. So basically, our lovely black cat there has been reduced to this very childish drawing of a cat, where you can see, well, yeah, I can see it's a cat, but it lost its color and lost its eyes. So that's not a very good one. There you go. So we have that's a word of warning, basically, about the synthetic data. And you have to have a lot of other validations, human validation, before we use that. Okay. Oh. Right. Let's move on. So with our medical data, we have done some work with some synthetic data set. And what we have found out that some male patients were expecting. That's always the one make us a big laugh. We have found as well that some people died several times in different places and from different diseases. That's not very good, that one. And as well, we did find out that some pregnancy lasted 18 months. So that's this type of things you find for validation of data set, and a lot of human works is made behind the scene just to remove these inaccuracies. All right. So we've looked, once we've done this data there, and we've been aware of that, we looked at for coding for to prevent disclosure. So what we did, we use a black box, basically, and it's not a black box in terms and you don't understand what's happening with the code behind it, because what we use in DataSHIELD, it's an open source software. People can have a look at our codes. We've got people who just fork the whole code and just contribute to our development. We are not all that. But what we're doing, we put the data in a black box such that once it's inside, you cannot get it out, okay? And what we do, we just only provide metadata. So if people works with using databases, that will be the data dictionary. And that's what will have the name of the columns, the type, and how many observations you've got. That's all you do, but you cannot have access to one particular information from non-disclosive federated analysis. Then we've got the client. Then you've got this client script or function. It doesn't have access to the data directly, but it can obtain some results and some computations. I'm sorry I stopped. I've got Paul Burton on the phone, keep texting me about some suggestion what I could tell you actually, basically. And it's telling me basically how complex mathematical can be. So, and the number of observation in each source. Yeah, and I've told that everything already. So thank you, Paul. How kind of him. Right. So what we have there, we've got what we did in our server. And I'm sorry if you don't really know about what OOP is. What we did basically, we had access to all our data, which is on the left-hand side. And based on that, we just made them private. That means if they're private, in OOP, you cannot get access to them. In R, it's slightly dodgy because from RStudio, you get access to them. In other programming language, you cannot, okay? So that was to simulate the server, and our data server, like you will see later on, the data, you don't get access to it. And what we did, we put a parser, it's more grammatical parser, where we passed on all the name of the function we can do on our server. So we have server ls, which lists all the name of our object, for example. So it just gives you the name. Oh, you've got this data set there. It doesn't give you more than that. You've got the dimension of this data set. You've got the minimum, the maximum, the factors. You had the mean. You have the standard deviation as well in this example. And when we try to get directly to our data, then it said, no, you can't get access to the data. There's no data there. Fine, that's it. Well, in non-disclosive federated analysis, you just don't have that. You just cannot get access to them. You can't even get any calls to them. That's as simple as that. But what you were able to get is the list of our data set. Oh, we've got a synthetic data set. We've got that one, it's not. We had a look on the third line, which is like server.dim. We were able to say, oh, I've got a grid read score, the number of words and the publications. Then we were able to do some mean, some standard deviations, minimum and maximum of it. That's fine. So from that, you can have a sense of what's happening with your data set. But based on that, we had a look at some client-server architecture. So as we're repeating things, what we did, we had a client function, and this client function, it's often a library, an R library that lives onto, or any other programming languages, but we're in an R conference, that lives basically onto the client, onto your RStudio, onto your computer. And then you've got a server functions with a lot more server-side software to give access to your server sum, mean and less, and your server function will call the server function and do two types of analysis. And the server function then will get access to the data. So we add another level of security to the data, basically. It's the server function that does it. We've got two types of analysis. We've got what we call the virtually joined analysis. Okay, and what we do, we generate, I don't want to use the word simulating, we give the impression all the data have been put in the same place, source, and then we give the answer. But that doesn't happen. We use some clever computation to give you this impression. So I'm currently working on a non-parametric test, on a non-parametric statistic and test of that, because at the present time we've got only approximation, which is pretty accurate, but we wanted something even more accurate of that. So try to calculate a mean or even rank the data without sorting them and putting them in one same place. Well, that's pretty hard. So we're doing some pretty clever calculations behind the scene, how to do that, to give you this virtual region analysis. That's so much fun to do it, guys. I tell you what, that's so great to do it. But some people as well want to know for each server or cohort of data, what's happening there with this data. So I have to do some comparison. So the second type is the server level analysis. And what we do with that is just give you the result for each server. So here, look at the little gray boxes on my slide. You have the combined for the 3 data sets. The mean of the year of the publication was 1936.5, according to that. Well, let's say 1937 to do an accurate, basically rounding. But then for each data set, the data set in London was 1941, still rounding the data. In Newcastle was 1928. And in Edinburgh was 1936. So as you can see, you can have a better feel of the data, how they work in each server and combine. Some people want to do some virtually join one, which is great. Some people want only to do some server-like, but again, you can do a lot of nice comparisons. So that's the way the coding looks like. You've got what they call a DS mean, and you do only one call, and DataSHIELD work the same. You've got one call, and that's a very simplified way of coding it. Well, you do only one call, you pass your connections to your servers. That will be your IP addresses, and that's it. Here, it will be your address to your object, your variable name you're going to use, and then whether it's combined or not. So combined means virtually join. And if it's false, basically in its server level one. And if it's basically combined, we do the combine.mean. And if it's not, we do the split one. And what we would do there, and what we would do for the combine, we would just do the sum. We would call on a server, make a big sum of each data set and add them up together, and use something called, in our example, log server length for each of the data set. And then we've got the total divided by the sum divided by the total of observation, and we get our mean. What is the split? We just get all our different mean from each server, and we put them in a nice format so that they can be readable. That's all it is for the mean. The rest of them, like doing a GLMO or GLMMR, or even more, or some mediation analysis, which we're working on now, can be a bit more challenging. Even the Cox survival analysis is even more challenging, which we're working on now. So from our value, there's still some elements of disclosure here. We had our factors, especially like on a small data set, which was Edinburgh, which only 5 data. We had a minima, we've got a maxima, we've got an arithmetical mean, we've got a standard deviation, and we've got a length. So it took me only 2 minutes to basically do us a few combination of the values, as you can see there, and then find out that what you've got there, then you can reconstruct your data set. And according here, you have basically is the 3rd version of it. And the 3rd version of it there is basically the one that is correct. And I reconstructed my whole data set. So I've just used a simple inference there because I had the factors, I got the minima, the maxima, and I had a small data set. If you had a lot more than 1,000 of them, but still a very close, very small standard deviation and your factors, well, computation-wise nowadays, and a big computer system, you can still reconstruct them. So what did we do to overcome that? Well, we've got the client function there. And what we did, we just leave the factors Okay, we still use the mean, we still use the server sum, but we don't have any minimum and maxima because they're outliers. They're quite small cells, so we don't want them to be identified. So if you've got some observation on some vehicles and you don't want these vehicles to be just identified, you may have the same issue there. You have definitely to remove your mean and your maxima, whatever you do. We left the factors as well, but what we did, we used some new parametrization, which we call threshold. And these thresholds, they let the data governance, the people who stops being, who is in charge of the data, to basically be in charge of these thresholds. And if they being an intelligence or made the mistake just to put a wrong threshold and not testing it, it is a responsibility. But we would strongly recommend them to verify that and make sure they feel comfortable with the type of threshold they do. And this threshold will affect what's coming out of the server. So what we did now, we had we've done our we've written our DS mean, and you can find the code on our GitHub. On our GitHub, and what we did find there, we had a look. We just show in London the total, the number of observation. A total is a total. You don't have any factor, you don't have any minima, maxima, so you cannot recreate it. But look at Edinburgh. It is said server warning. Server warning, not warming, and it's the disclosive call. Because you only have five elements there and a sum. And again, with a big, with a simple code, you can definitely reconstruct this sum with a bit of computation. So when we did our DS factor, basically, we were told that, oh, we cannot get any data because they're still warning us, it's a disclosive call, because all this value, this call, they were quite unique, and you were able to reconstruct quite easily the whole data set. But factors are still very useful, by the way. So let's imagine if we want a gender, male or female. That's interesting. For our data set, we added a new column. We said, is it electronic, hardback, or paperback? That's something made up there. And what we've seen, and now in London, we know we've got some electronic, hardback, and paperback. And based on that, I could probably use some more advanced technique and do some grouping, which we would offer in DataSHIELD. And if it's disclosive, then we are basically, we will tell you. But Edinburgh, we got only 5 row, and we just cannot see what's electronic, hardback, or paperback, because only 5. The threshold has been broken. It's just higher than the threshold, so we just cannot do it. Okay. But when we combine them together, we know for these 3 data set, we've got electronics, hardback, and paperback. That is fine. Okay, you're not telling us more. Okay, so that is why it's very important. So what we have there, what we have done, we have no direct access to the data. I would be quite straightforward with you. If a system, they give you access to the data, directly access to the data, although they left somewhere on a big data center and that's it, that is something not recommended. But then we use a parser to constrain the data number of analysis to complete. So like this, we have found issue with them. We know about this simple inference. Then somebody so 16 years old, they listen really carefully what's happening in the math lesson, they can redo it. And then we limited the data inference by using some thresholds controlled by the data governance. So we give this ability to do that. And that is very important because some people may be stricter than others. For example, I give you an example that we've got the national statistics office in the United Kingdom. They got some data set where you can only get access in a dark room, and they didn't got any window, and you cannot take any set of notes, basically. Or if you do, they just review them, and they might take them from you out if they are too disclosive or whatever, and you have to get access to the data. So that's what this type of things we're doing here, basically. We are trying to say it's up to the person who wants the data, where we've been given confidence to it, should be managing that. So there you go. So we went back from the stormy weather back to the sunshine now. So DataSHIELD architecture, that's the real thing now. That's what we do. And that's what we've been simulating now, by the way. So at the bottom, you've got the analyst. And that's the person who writes, the analyst, the data scientist who writes the R script from the R studio. And what these people do, our DataSHIELD client library will give you access, a method to connect by TCP/IP and HTTP. We recommend that people use HTTPS for safety reason. To some DataSHIELD server. Now, this DataSHIELD server, the data governance will give them the IP addresses, the unique password, and the unique ID to log on to the data. And that we will basically bring the calculation behind the routers. And can you see this big red line, or quite small dotted red line? And that is between the router. So when we're communicating, then the router must give us access to this server. So it's not unusual for an organization to block very strict routers to ask basically, so which DataSHIELD, which door do I need to open, basically, which address and which protocol do you use there, and address do you use, just to let us in to have access to the data. So by mentioning that, it's not only, us saying that, oh yes, you can just use it. Often we talk to the IT department, to the people who do the IT security, to the IT services, and all that. There's quite a lot of people who are involved into it. Now, the client side, that's the easy part, kind of there, because behind it you've got what we call a DSI, a DataSHIELD server interface, that will let us to connect to a lot of variety of databases, not only relational database and document databases, but as well genes-based biological database, some result of some Unix command like SSH, or even some outcome, some very unique systems we've got behind that. And we're not completely against to AWS, Google, and all that. If the data governments want to use them and want some data to share there, we can give them access. We have the technology to give access to these facilities as well, data warehouse. So here we are, we've got our Opal server. Our Opal server, it's a specialized web server because we're a RESTful system. And this specialized web server, it will have our parser will basically look at the grammar. And if you try to say, give me the data or one row, it will say, the computer says, no, you just cannot do it. It doesn't reserve null. It said error server, or you just cannot do it. It will as well give you it will give you as well access only to a limited amount of functions, which you will know about, which the client function will know, and they've been the coders, us, will make access to. Now, the Opal server as well got some databases when you can run locally on one machine. And then what it will do when we start the session, it validate who you are. You've got the right login, the right TCP/IP, the IP address. And once that it's done, it will start what they call an R session on an R server. But our server is the second bit of software that we're using. We've got a Java interface, another, which is basically highly specialized just to give access to the data with all the security of it. And once we're in, we create an R session, and all the data, if you use a database, you use a database, is extracted into a data frame, into your R session. And you've got only one letter, like you will see from Alex soon, is demonstration and lady, and you can only go through it and just in your function call, use that name of a column and use basically and do this aggregation of this assigned function on the server. We're using this data. So that's what we do. So we not only, you know, encouraging people to anonymize the data, but we are as well strongly, we're just bringing the computation to the server and making sure the results are non-disclosive. And we've got as well the threshold. The threshold are there. And if you do a GL, a GLIM, or a GLMR, you've got that could all this, the modeling fittings there can be quite disclosive. So there is a lot of limitations there that we had to put into it just to prevent limitations. But that is the statisticians who have looked at it, and it's quite a complex element to do. Now, the one at the top where you see the word resources, we appreciate not everything is stored in databases, because just talking about our weather data, to come back to it, they got different sensors, they got large CSV files, probably XML files and all this thing. Other people may use that, especially if you work in engineering or different vehicle and different format with them. So what we did, that's completely new to version 6, that, and completely new out of the oven. We got what I call some resources. And our colleagues at Obiba and Progeny, who are working with us and developing the Opal server, what they did behind the router, the data governance can give access to different databases, different computation software, and different files, still within the organization, still behind closed doors, still being bespoke system as well, by the way. And then the data can be made available to DataSHIELD, where basically they can be integrated with other people, or can be made available in different consortium or different people using different type of systems. So if some people use some databases and some people use some CSV files, they can still share the data, the same data with the same metadata within, and the analyst doesn't have a clue what's happening, what is the format. All they know, the DataSHIELD analysts and data scientists got access to some data and some outcome. That's quite a complex diagram. That's quite a complex architectures, and that's why if you had access to it, and if you had the time to go through again the exercises, you will see all these ideas, these complex ideas have been put in this DataSHIELD architecture. And that is why it is trusted by not only basically by German hospitals, and as well as internationally. So inside the Opal server, I wanted to make sure of that, you can get normal traditional databases there. And you can get as well access to a lot more type of data, which is genomic data, gene databases, cloud-based storage, comment to some existing system, SSH, and any organization-specific data storage systems. But within the server there, it's the data governance, give access to it. That's the people in charge within the organization. Okay? That's not us, Newcastle or DataSHIELD people. We help you to do that, that is fine. That's what we do. So we've got, like I said, a RESTful interface. RESTful means we do some HTTP call, and because we are security conscious, we will definitely encourage people to use HTTPS because it encrypts all the data, And even now, many web browsers don't accept anything with HTTP. So anyway, that's what we do.
A particular month and see how the cases change over that month. So what we can do is use subsetting. So the particular DataSHIELD function for subsetting is ds.dataframe subset. So various arguments in this this identifies which data frame we are going to subset. This identifies which variable of that data frame we're looking at, and we're applying a Boolean operator to it. So we're saying when the month is exactly equal to 1. So that will build a new subset, which is all of the data from January. Data sources connections just refers to that that login where we connected to the server. So we can run all of this, and we'll build subsets for all of January through to June. This will take some time as it's communicating with the server, and then the server is running, well, is computing all of the subsets before sending it back. So it took that amount of time to do January. It takes a little longer to get all the way through February, etc. I'll cancel it after April because I can just show you the scatter plots for a few of them. This is April. So yeah, I'll stop it there because it's done April, I think. Yeah, stopped. So now we can actually use those subsets and build new scatter plots. So it actually hasn't stopped. It kept going to the end. Anyway, so we can try and do ds scatterplot. This time the object we're looking at is not D for the entire data frame we originally locked into, but the object is the newly created subset. We're comparing the subsets, just January's days against January's cases. So if you run that, it goes away to the server, tries to create the scatter plot, but comes back that there are some errors. So if you actually investigate the errors, as it suggests, the message will be that there's so little data in January that it's disclosive. So we can't see it as the analyst. The server has performed checks to say that there's that creating a scatter plot for this particular month might give you insight into individual data points, which is the whole point of DataSHIELD, not to allow that to happen. What about a scatter plot of February? And I need to make the window large enough. There we go. So that's a lot more informative than those overlaid plots before. So very important to note is the different y-axis scales here. Asia in February is already in the multiple thousands, although a slight decrease over that month. Europe, as we all unfortunately know, very rapid increase at the end of February somewhere in Europe. Obviously, we contextually know that might be Italy, but there's nothing in this plot identifying anything really other than the general trend of a slight increase, well, an increase at the end of the month of February for Europe. Other continents stay very low, relatively speaking. And then have another look at March. So just worth noting that the way that scatter plotting works in DataSHIELD is interesting in itself. There is a link in the wiki article for my demonstration about how scatter plotting works, how it works non-disclosively. It was developed by our colleague Dimitri Evram in Cyprus. I think that's
You've got
fine.
3 more minutes, Alex. Do you want to talk about
Yeah.
your normalization, please?
Yeah,
And then I'll
will do.
Lady. Sorry to.
It's okay. It's hard to see the timer when I'm in our studio. So if we get to conducting the analysis, it'd be interesting to normalize for population. So what we want to do is create a new object on the server side, which is doing a calculation to a vector. So the DataSHIELD function to do that is dsMake. So it toAssign contains the calculation and the vectors to do it on. So I'm dividing the number of cases in each geographical area by the population in that geographical area and timesing it by 1,000,000. So it's effectively calculating cases per million population and calling the new object and again data sources. So we make this. These returned statements show that it's successfully created, and then scatterplot with the x-axis being day of the month again. This is across all months, just to see the worst cases across any of the months. And this is scaled, so this is in Asia. At the worst of it, there were 600 cases per million population in whichever country this is. We don't actually know. Then if you want to do mean and variance, we're wondering about how the distribution is of cases across the months. So we're effectively trying to calculate, see if there's a normal curve of this data. Well, to start with, that doesn't look very normally distributed with such a heavy skew towards the bottom and very extreme outliers towards the top. So what we're going to do is use a linear modeling technique, which is scaling it by square root. Again, dsMake performs that calculation for us. And then ds_scatterplot again. Taking some time. And there we go. So we can see that that transformation has shifted everything up. There's a more even distribution across the number of cases, scaled cases. Then we can graph this using just assigning in our studio the results of dsMean, which calculates the mean for that vector, dsVar, which calculates the variance, and then I've square rooted the variance for standard deviation, and then actually plot it, which I just need to avoid the install packages. So, and I'll add a polygon. So this, assuming the mean and variance are what has been calculated, this would be the distribution of them, but we know that no case numbers can be below 0. So the conclusion I would make here is perhaps those data are not normally distributed. We'll have to have a think about how else they could be distributed. So that's the end of my demonstration. There are plenty of other questions we could ask these data. Perhaps find the right distribution for them, or plot a scatterplot of cases to deaths, or I've made a list of 6 other things we could do here, but feel free to download the data and do them if you'd like to explore DataSHIELD.
Well, thank you very much, Alex, for doing that. What we just demonstrated is how basically DataSHIELD can be used, which we're using some servers. So now we've got Lady. Lady, are you okay?
Yes, I am okay. I was having problem with my internet.
Okay, brilliant. Oh, that's fine.
But,
oh, sorry to hear that. Lady, while Lady's setting up, is going to, she's in north of Spain, actually, and where she lives and worked with us there. And she's going to demonomics demonstration, and she's going to connect from San Juan, I hope, or San Sebastian, sorry, to Barcelona, to one of our IS Global collaborators. So then if everything goes well, you will see, hopefully everything goes well, the internet works fine, how basically the connections, we can actually really do remote calls using some data. Right, off you go, Lady, you are on.
Yes. I share it in the chat, the link to my presentation if you want to join and follow from there. And I am going to share my screen now.
Brilliant. The
Okay.
stays there until whenever you want to use it. Go back into it and contact us whenever you need some.
Okay. Can you see my presentation here?
Yes, we can.
Okay, so I will start. In this presentation, I am going to explain how to configure the Opal server and the client side to perform a nomics analysis, and also at the end I am going to do a small demonstration to show how this can be done using DataSHIELD. For those who are not used to do this type of data, here you have some brief explanation and also some links to more information if you want to read. And first of all, to make the connection to the server, as Patricia has explained it, we need the resources features that allows the interaction with existing data repositories, and instead of storing the data in the Opal database, you connect to the server using a URL, and the data is still there in the original format and location. Now I am going to explain how to configure the server. To analyze omics data, we need the DSBase, DSOmics, and DS Resourcer package. DSBase is already installed if you are a DataSHIELD user, and you only need to install DSOmics and resources. For that, you need to go to the Opal server, to the administration site, and here in DataSHIELD, you have to install in this tab. Already they are installed, so I am not going to install now. Also, it took some time to install. So, and the thing that you have to type is this that you can see here. After this installation, I am going to explain how to declare the data. The data that we are going to use is a transcriptomic data, which is in IS Global server that is in Barcelona. And this data is from Estonian Biobank, which is a population-based biobank of Estonia Genome Center of University of Tartu. The data is IS Global. We collaborate with IS Global to generate the DSOmics package, and the data is here. For this analysis, we don't need to download the data, but if you want to analyze the data more in depth, you can download and analyze, but for DataSHIELD is not necessary. So we need the URL and the data name. So we need to go to the Opal server, explore the data, and then go to the resources. And these are projects that I have created already. And here we need to go to this chain, that is the resources feature that is installed in the Opal, and add a resource. Here we need to type the name, for example, test. The category is HTTP because we obtain using this protocol the data, and it's a R data file. And here, as I said before, we need to put the URL, this, and the name of the data file. And here the R object class, that is an expression set. And then save it, but I have already this data here. So for the demonstration, I have already declared in the server. Okay. And when we have configured the Opal server, also we need to install some package in the client side, that is the RStudio. And if you already are DataSHIELD user, you normally have this free package installed, so only you need to install the DSOmix client through this link, pasting this in the R console. And now I am going to perform the data analysis. I have already here all the results of the data because it took a long time in R, so I am not going to run now all the RStudio. So first, we connected to the server as the same way as Alex does before. And then we need to coerce this data to expression set. For those who are not familiar with this type of data, expression set, you have here the explanation. That is a bioconductor data class and combines different sources in a single structure. But we have to take into account that we can access to all this data and print in the client side because it's non-disclosive. So now in the next steps, I am going to illustrate what type of information we can obtain from this type of data. First, we can calculate the dimension of the data. We can obtain the features and the samples. Also, we can obtain the features name, and there are a lot of features as we can see here. So we can see the first one using the head function. After that, also we can obtain the variables name, the age, gender, and this inversion. And we can analyze the age, that is numeric, creating some histogram, as we can see here. And with the histogram, we can see that the minimum age is more or less 18 and the maximum age 84. Also, we can analyze the mean that we can see here, the variance and the standard deviation. After that, also, we can analyze the gender. That is what the variable that we are going to use in this analysis. And I did here a table to see the number of females and males in the study, and we can see that there are similar numbers, quantity of female and males. And now we are going to use DS Lima package to generate a differential expression analysis. This DS Lima function is like integration of Lima package of bioconductor in DataSHIELD. So basically, it works the same in the same way as Lima package of bioconductor. So we want to compare the gene expression level between females and males, and after running Lima, we obtain this table that here we can see the ID of the groups of the genes, and also is useful for this analysis the log fold change at the adjusted p-value. And also I have to mention that after obtaining this result, to continue doing the analysis, we don't need to use more DataSHIELD because the data is already in the client side. So we can analyze using native R functions. I am going to do now a small explanation to see that we can use the native R functions to analyze this data. So I am going to identify the over and underexpressed genes in these results. And for that, I am going to use the log fold change and adjusted p-value. For that, who are not familiar with log fold change, this describes the log difference in expression level between experimental conditions, in this case, the females and males. And here you have a visual explanation that explains very good what is the log fold change. So first, I am going to select the statistically significant genes using the adjusted p-value. After that, from these statistically significant genes, I am going to select the overexpressed, the genes that have a log-fold change greater than 1. That we can see here that there are 7 genes. And also, I am going to select in the same way, but with a threshold of -1 log-fold change, the underexpressed genes that there are here, there are 11. So in total, we have 18 genes differentially expressed.
Lady, we've got 5 minutes left for the whole workshop. Sorry to interrupt.
Yes, I am finishing.
Okay, no, that's
1
fine.
second only. Yeah. So also it's important to know that after doing all this analysis, we need to log out from the server. Otherwise, if we want to do another analysis, if we connect again, we are going to have a lot of connection and the server can get stuck and stop working. And that is all my presentation. If you have any answer, any question, I can answer it. Sorry.
Thank you very much for doing that. And we always run out of time in this thing. I'm sorry we don't have more chat to do there. But just to conclude, well, I hope you did find it very interesting for what we say. And hopefully you can see who is the core DataSHIELD team here on the screen. It's not only myself, Alex and Dimitris, but it's a lot of international people where we speak not only English, but French and Spanish. And I'm sure Dimitris speaks even more languages than us. But as well, some people who now move on to Liverpool University. Yannick Marcon is the person without our Opal server would not work at all. And without Professor Burton, who initiated it with actually Epigeny in Canada, then we wouldn't be here today. So there you go. It is all these people here. And I have to thank especially Elaine Smith, our communication manager, for just going through all our slides and everything to make it as comprehensible as possible we could do today. Right. So, any questions? I hope you enjoyed it. And what I wanted to say, well done to Alex and ladies. The first time they've done that to such a fantastic audience on this type of tools, to an international element. So well done. You did very well. I was impressed. Have you got any questions? If you want to come up and chat with your camera, you're more than welcome, please. If you're still interested, I don't know whether the room will go bang in a second whatsoever. And I don't know what will happen, to be honest with you. Sometime we'll close. If you still would like to please contact us, go onto the GitHub. I think and you can contact us on DataSHIELD email address. I'm going to give you, I think, some links where you can find us. Then the wiki, you can get access to it. You've got all the contact details. If you had put your names down to the workshop previously, I did email you yesterday with even more details so that you can even contact us. You can contact me personally, Patricia Ryser-Welch, or the DataSHIELD team, and we're more than happy to help you and working with you. We are an international team. We work with other organizations who do develop as well some functions. We've got some people in Cambridge, some people like ICE Global does all our omics, but Lady, she's a very good biostatistician and she does some development with us. My interest is a non-parametric, more parametric and non-parametric statistics. And once we sorted that out, we will going to do some machine learning algorithm in a non-disclosive way, because machine learning, I believe, can be highly disclosive in the type of information you can find, and we want to do it in a right way.
and make it explainable and interpretable as well, because that's another important element that we need to do.
Patricia, it doesn't seem to have auto-closed. Are people free to join the talking chat?
That's excellent. That's an excellent news, Alex. Yeah. Can you stay a bit longer, Lady and Alex, or not? I can stay until midday here, 12 here, 1 o'clock there, as long as the thing stays open. Right, Mahid, or sorry for mispronouncing your name. Okay. Yes, what we do basically, when we develop a function, Mahid, what we do, we just first develop it in a very disclosive way, I must admit. And then when we find the element of disclosure, we add the threshold to our functions and reduce it even more and more, such that we're happy to the quality of the disclosure. So that can take quite a long time to get something ready. So what our next set of development, what we are going to do, it's having free model of DataSHIELD to help our developers to become more efficient at it, which we call it the ABC model, where A is the classic model we were showing you there today. B is the C is basically the most disclosive way, but that will give access to our developers and our users to have access earlier to some functions, earlier to that, with a big red flag to it, don't use it with sensitive data. And then once the DataSHIELD team and the people involved in the disclosure settings can validate this non-disclosive, the function is non-disclosive, then the function and the development will move up from the C to the level B, which is the middle term. And then when we satisfy all the disclosure settings as bring in control and prevent any disclosure of data, then the plan is to move any development back to the classic DataSHIELD, the one we discussed. We came with this idea because we do a lot of work to assist people on the disclosure setting and to make it non-disclosive. And I call it a bit like a magic trick or black art, and it is a bit of a black art, and we appreciate that, but we're happy as well to help with anybody who wants some help with that, and to develop DataSHIELD more as a project, as a software that can be used more widely and bring it to more people. Did I answer your question, Mahid? Can you hear me? Oh, Alex, are we still on or not?
I believe so.
Okay, I'm not talking to myself there.
Yes, I am already here, also here.
That is fine, that's all right. I'm just not sure if people are, okay, that's fine. Have you got any other questions? Please ask your questions, we're here to help you, don't be shy. I've asked tricky questions all the time when I was assisting it. Okay, go on, Christophe. I think it's the system got a delay, and I'm personally rather impatient. That's why I should stop being like this. What you can do with scatterplot, what we do for scatterplot, we've got a K nearest neighbor, how do you call it? A K neighbor, nearest neighbor anonymization. And the way that's working, this K neighbor anonymization, look at the small set with the outliers, the one we don't want really to identify. Like I was using the person with bright red head. There's not many people, so you can see them. So for that, any non-disclosive statistic will say there is less than something, but that's all. They would not give the number. So for that reason, we do that with the visualization. So ggplot doesn't do that, but what you could do, what can be done, the graph coming out of the scatter plot, I believe, can be saved as an R object. And yes, because otherwise our studio wouldn't show it. And based on that, perhaps you can go and put it in ggplot. But ggplot doesn't offer the visualization and the disclosure protection and the privacy preventing features that we offer. Yes, and to be honest with you, we've got like something like a scatter plot. Us in research, we love using scatter plot, but that again, you've got quite a lot of, well, the outliers can be definitely be disclosive. So that's always this little element, you know, of disclosiveness. But I feel, Christophe, we need to get in touch and probably have a chat and see how we can probably help you. Sure. And I take it you're based in France. We can do it in French as well if it need be, if some of your colleagues prefer it to do in the language, but we can do it in English too. So there you go. Actually, I will type my email. Oh, brilliant, that's fine. When I worked for a consultancy a long time ago, and I was sent to anything we used to do online because a lot of people were asking for translation. So I used to do that. So if you wish to contact me directly, you can contact me. I'm typing my email address here now. Please contact me. I know it's a very long name. Copy and paste it. Contact me anytime. And that's for the people attending. It's for as well all the people attending. Please do. Brilliant. Majid, please contact us as well. Anybody here wants to contact us, go and find us on our GitHub, on the GitHub especially created here. Contact us as well on our datashield.ac.uk. We're there to help you, and we would like to hear from you and collaborate for you. What we tend to do, we tend to help people in research grants. We are part of research grants as well. And in the future, we're looking for more collaborations, to be honest with you, because we need every time to get some funding. Otherwise, we're not going to work. So I'll be cheeky to point that out at the end. But if anybody wants to work with us or do some research grant, help us with your research grant and all that, and give us some money or work with you, we're quite happy to do so. Just contact us. A lot of people did that in a conference, so I can say it. Well, I'm glad you liked it. And actually, we're looking at to develop more our omics packages. So if you know anybody who wants to join ISIS Global and us, please do. That will be fine. Any other questions? Okay, I'm glad you're saying that. What we have now, we are conscious that the user interaction is based on your command line interface, which not everybody is keen, but because originally the people who created it used R, and a statistician who liked typing command and who knew R very well, and that's what they're comfortable with. We appreciate it is not everybody's cup of tea. So what we have, our colleagues at the Open Lab at Newcastle University, they are specialists in user interaction design. So we don't believe good interactions come from good coding or using just Shiny or doing that will solve all the problems. So we are currently having some workshops with our DataSHIELD users. How basically we could write some design our interfaces so that they meet their needs. So that's what that. But if anybody who attended today wish to take part to that and what they feel, please let us know. Contact me. I will pass your detail on to the Open Lab. and David Kirk, Professor David Kirk, who has kindly shared some of his PhD student and researchers to do just for that. So we're using it a proper user interaction design using the psychologist and the specialist. And then we will be implementing it. And I think we've got a deadline for December to have some user interaction graphical interface that meet most the needs. Oh, further on. Yeah, well, what type of psychological research you mean? Are you what do you mean then? Oh, I will have to have a look at that. I'm sorry, but my German is not very good. I haven't studied it for many years.
If you're in Chrome, Patricia, you can right-click and translate to English.
Oh, I don't. Okay, I don't trust the translation. I've done it enough in French, and I'm appalled with that. But I will definitely have a look through that. Majid, why don't we get in touch and see if you want to do something there? We're quite happy to do so. That would be grand. Thank you. Alex, do you mind to do the translation for us?
Pardon?
Do you mind to do the translation and get back to us on Tuesday, please, about that, please?
I'm confused. I don't
about the
so.
OSF thing, right? The link that Majid sent with us. Do you mind to save it somewhere and translate it for us, please, for Tuesday morning meeting, please?
It, yeah.
Thank you very much. Oh, great. So I might be in touch, actually. Any other thing you wish to discuss? Thank you very much, Christophe. Au revoir. J'espère qu'on peut peut-être vous aider à Airbus. Je suis suisse d'origine, c'est pour ça. J'espère qu'on peut, que la semaine prochaine, peut-être qu'on peut avoir un catch-up, d'accord? Right. Well, thank you very much. I'm glad you like it, Magic, and I won't speak German. My German is atrocious. But please keep in touch again, and hopefully we can collaborate together, and we can probably help you with some of your research. You never know. Right. Massa, have you got any questions if you're still here? Serena, have you got any questions? Steph, have you got, if you're still here? And Andrea? Well, you're welcome. Can we help you in any way, or shall we keep in touch? Would it be useful for you? Oh, brilliant. So get in touch with us, please. And hopefully we may be able to help you with that. And please share us with your colleagues and your department. Probably we can help them. We would love to hear from them too. Thank you very much for coming. We hope it was very useful. Brilliant. I love big data analytics. So there you go. And right, I think we're going to draw it to a close now, unless people have to say we're going to say bye now. I think because there is some lunch going, join lunch if you want to go and join that, the other people there. And my headphone, actually, my earphones are going, I've got no battery left in them. So brilliant. Thank you very much for attending today. I really enjoyed the small amount but good quality people, and I'm glad that you find it useful. We really enjoyed that. So from me, I will say bye-bye. Alex and Lady.
Yes,
thank you.
Do you want to say something?
Thank you.
Bye.
Bye.
And brilliant. And bye. And Alex and Lady, have a good weekend, and I'll see you on Monday or Tuesday in our meetings.
Yes.
Okay. Bye. Thank you very much again. Cheers. Bye.